So we need to talk about how IPv6 gets subnetted. And we've talked about IPv4 already, but I wanted to go back over that and do a little review. So here you can see the pie chart version. So here is a class C with 256 IPs. And what they've done is simply divide it into some fairly large sections. And then one of these sections has been subdivided even further. So if we think about that pie, like so. In a class C, you get 256 addresses. Now, there's only certain ways you can cut a pie in IPv4. That is to say, only ever can you cut a piece in half. So if we do this, we get 128 over here and 128 over here. And now we can do the same thing. We can cut one of these sections in half to get 64 and 64. But we can only ever cut in half. We can't make any other type of cut. So if we need, let's say, a /30 for a point-to-point network, that gets you 4 IPs. And those 4 IPs give you the 1 reserved for the network address, the 2 that are actually usable, and then the last one is reserved for the broadcast address. So we only get 2 IPs out of this, which is perfect for point-to-point links, because that's exactly what we need, no more, no less. So if we need to break those 4 IPs out of this pie, we can divide this into 64, and then that into 32, and then that, and we have a couple of 16s, and then that, and we get a pair of 8s, and then that right there. And now we have 4 and 4. Now this one's still broken into 8, and this one's still 16, and this one's still 32, and we can break those down further if we need to. So this is the trick behind IPv4, is that it's only ever divided in half. And the reason I wanted to review this is because this is what's different about IPv6. IPv6, we can make much smaller cuts and much easier cuts.